The topic for my research paper is a hybrid database approach using graph and relational database. My roll number is 23. I am Shreya Khitan from Division A. The publication is IEEE and it was published in the year 2018. Introduction. Database industry is facing a major challenge in gaining scalability and handling multiple databases in one application. Relational databases have been the university industry standard for almost as long as databases existed. It is undoubtedly useful for storing tabular data that fits in a predefined schema. SQL becomes complex when handling large databases. Larger the database, more is the number of joins, which ultimately leads to an increase in query retrieval time. However, due to enormous growth in distributed databases and massive use of social networks, new requirements have emerged and graph-structured data is becoming more and more important. Graph databases can store graph data more naturally because of its ability to analyze the data in non-relational format. Example, a social network data. Relational databases and graph databases both have strengths and weaknesses depending on the characteristic of data and the type of query to be evaluated. So what type of database that we use, whether it is relational database or graph database, depends on the type of query that we have to evaluate and the type of data that we are using. However, benefits can be obtained from taking parts of both together. So since relational database and graph database both have their constraints and limitations, we can take the benefit of both by taking parts of both and using the advantages of both relational database and the graph database. Thus, design of hybrid model is made such that the two models are integrated in one system to eliminate the limitations of individual systems. The hybrid system unifies the strengths of relational database and graph databases by analyzing their strengths and weakness. Relational model. The relational model offers a very mathematically adept way of structuring, keeping, and using the data. So let's have a look at how the relational model looks. So this is basically a representation of the relational model. A relational database consists of tables, each of which has a unique name. So we can see in this picture that this is a table. A row or tuple, this is a row. So a row or tuple in a table represents relationships among values. Thus, table is a collection of such relationships. A tuple or a row must be distinguished from other tuples in terms of its attributes. That is, every tuple must be uniquely identified. This is achieved by defining keys. A key is used to uniquely identify a given row or a tuple in a table. A key value is distinct for every tuple. Further relationship constraints can be added by defining foreign keys. Additional other integrity constraints can also be specified. There are different types of keys and integrity constraints that we can add. Also, a query language is required for users to request information from a database. So now let's look at how a graph model looks. A graph database stores information as relationships between the entities and represents this data using nodes and edges instead of using rows and columns in tables. So as we saw in a table database that we used rows and columns. However, in a graph database, we similarly use nodes and edges. Graph databases are typically thousands of times more powerful than conventional databases in terms of indexing, computing power, storage, and query. So now this is an example of a graph database. As we can see, each node represents a piece of information entity like a person, place, and everything like that. And each edge that represents the relationship or connection between the two nodes. So now let's look at the final hybrid model which combines both the table relation database and the graph database. Considering the pros and cons of both the models, it makes more sense to use both the databases together. So the proposed model focuses on building a hybrid database system for the storage and management of big data. Hybrid database approach or multi-database system is defined as integrated data systems composed of collections, two or more autonomous datasets. Here it is the graph model and relational model. So you can see this is basically a view or an example of what a hybrid database would look like. So here you can see a hybrid database is composed of a relational database and a graph database. We use the advantages of both to come to the conclusion of a hybrid database. So conclusion. So what have we learned from this paper? Thus a method for implementation of hybrid database system between a client and two heterogeneous databases which would be capable of decomposing and executing queries on multiple databases with the purpose of speeding up response time by allowing the database to work in union is proposed. In this paper, an extensive survey on various hybrid database approaches is done. So now let's look at the future scope of this. The next phase would attempt to implement the set concept to obtain the result. So this was basically an idea of how a hybrid database can be implemented, and the next stage would be to actually implement it. The reference was taken from SkyHub and IEEE website.